Hi everyone and welcome to ING Tech Meetups group. Welcome Nigel, I hope you can hear me.
Yeah.
Nice. So my name is Nikita, I work as software developer in ING and today I will host this event. We have a very nice topic from Nigel, Kubernetes Master the Fundamentals. And before we start, I will just go through a couple of slides. So first of all, let's talk about our agenda. We will kick off in a few minutes, and one important thing that I would like to tell that we want this session to be as much interactive as possible. So guys, please scan the QR code and ask your questions there. So actually I can kick off the Q&A right now. If I just scan the QR code, let me try. I can already go and start asking the questions with the Slido portal. Yeah, so please do ask questions and Nigel will make a couple of stops during the presentation and we can have very good discussions. So this is Nigel Poulton. He's a Docker captain, author of a few books about Docker and Kubernetes, author of very good 5-star Pluralsight courses about Docker and Kubernetes, and speaker of leading tech conferences. I am sure many of you know Nigel already, so let's just start.
Hello, everybody. So I think we'll give it maybe a couple of minutes just to let one or two more people join. But while we're doing that, just real quick. So I'm in the process of moving house at the moment, and it's a very painful thing to do in the UK. I don't know what it's like where you guys are, but I currently don't have a home or an office. So I've set the office up with all of my equipment in my mother and father-in-law's spare room. So I think Nikita or one of the guys was asking me about the artwork behind. I've no idea. It's not mine. There is a cat in the room, but she's very old and very tired. So I don't think she'll jump on me during the presentation. But just in case, that's where we are. So I'm at my mother and father-in-law's at the moment. Pretty excited to be talking about containers and Kubernetes today. I would say just while people join, okay, so when we talk about mastering the fundamentals, we're probably looking at about, I don't know, 35, 40 minutes of me speaking and then taking some questions at the end. Now, of course, in that kind of period of time, nobody is going to master the fundamentals. But I think what we're trying to do here is give you an idea of what containers and Kubernetes are all about. And give you some options then to, I think, take your own journey of learning them further forward. So we'll kickstart things, give you some options, video courses, my books, things like that, as to where you can then go if you're interested to take it any further. Yeah. So I'm going to take a drink of water here. Nikita, is my screen being shared yet? Are we ready to go, or do you want me to hang fire?
Yes, I'm adding it right now. Oops.
Oh, wow, that looks cool. I don't know if everybody else can see that. Kind of looks like I'm looking into infinity. So if I do that, can you guys see?
Yeah. Super. I think it's now live. Yeah.
All right, magic. Okay, right. So let me just quickly run through who I am. Some of you may know me, some of you may not, and probably a lot of you don't care, but we'll do it really quickly anyway. So I'm Nigel. I'm based in the UK, a little bit south of Manchester in the north of England. So I have been doing Docker and containers and Kubernetes for a very long time now. Now, in the grand scheme of things, like, that's not a long time, but I've been doing them for at least 7 or so years now. Kubernetes itself, I think we first got it in the summer of about 2014. So that's about 6 years old, if my math is correct. So Kubernetes itself is not as new as some of us might think. Some parts of it are, don't get me wrong. But I think the core of Kubernetes is maybe a little bit more mature than some of us think. And we'll touch on that a little bit later. But I've been working with Kubernetes since then, and Docker since before then. So I've got I never use the term expert to refer to myself, because there will be a lot of people out there who know a lot more than me about all of it. But I've got quite a bit of experience, okay? I'm happy for people to reach out to me on social media channels, Twitter, LinkedIn, GitHub, places like that. Pretty much everywhere I'm at Nigel Poulton, and I am more than happy to engage with you and talk about containers and Kubernetes. That's all I really talk about online is technology. I've got to caveat that though and say I can't be free technical support for like really complex issues, but things that like maybe you're unclear about or uncertain, I can help with stuff like that. I've also got a website, nigelpoulton.com, where you can get my books, links to my video courses, things like that. So on the screen, I have a book on Docker called Docker Deep Dive and a book called the Kubernetes Book. If you look closely at the pink banners on both of them, they were both updated this year, and both books get updated at least once per year, because containers and Kubernetes are fast moving when it comes to evolving as technologies. So if those books were like 2-3 years old, they're not super useful for you because things have moved on so much. So those books get updated once per year. If you own the digital editions, like on LeanPub or Kindle, you get free updates. If you've bought the paperback versions, sorry, I can't ship you a free updated copy. But if you buy the paperback version, you know that it's a new book, okay? Yeah, I'm a Docker captain, and I've got a ton of video training courses at pluralsight.com, and they are so much fun to take. Nikita was just saying before, we super want this to be as interactive as possible, okay? So if you have any questions, please ask them. There are no questions that are silly or embarrassing questions, and some of the questions I'm not even going to know the answer to, okay? So if you have a question, don't be afraid or nervous to ask it. Please ask the question. It'll make the session more interactive, especially if it's something that I've covered that I haven't explained very well. Make sure you ask it, because you won't be the only person that hasn't understood it. And I'll just cycle back quickly and see if I can clarify it, okay? So questions, they are mandatory, and I think we're going to be awarding prizes at the end for at least the 2 best questions, and I'll help Nikita decide which are the best questions. And I promise you, they won't be the hard ones that I can't answer. Also, though, this is a list of some of my video courses at Pluralsight. I won't go on about them in detail, but they start at the top being the easiest and the most simple, going on to the more advanced ones. And I've got more than that. Maybe take a screenshot or a photo of that screen. And you can always search my name on Pluralsight for my other courses that get into a bit more detail. I'm going to take a quick drink of water, and then I think we're going to crack on.
Yeah, thanks, Nigel, for mentioning the prizes, and looking forward to your presentation and to the best questions as well.
Absolutely.
Thank you.
Please ask questions. So we will talk briefly about what a container is. Now, I fully appreciate that some of you will already know this, but for those who don't, we really need to cover this before we go into any more of a conversation around Kubernetes. Okay, so we'll talk about what a container is, and then we'll say, well, once we've got containers, why do we actually need Kubernetes, or why do we need a container orchestrator? It's a buzzword, but we will we'll explain exactly what that means as we crack on, okay? We will come across a few buzzwords, okay? But the idea here is that we will tackle all of those buzzwords and explain them as we go. And then we'll give some ideas of how you can get started with Kubernetes. And I'm going to say this right now, okay? When I was getting started in IT years ago, and I was studying for my MCSE in Windows NT, it was actually really hard to get your hands on infrastructure and build and trash NT domains and things like that. Whatever it was that you were learning maybe years ago was quite hard, whereas today, we live in, like, I say this all the time, okay, but a golden age of learning technology. So the ability to get your hands on with stuff, and then video training courses and books and things like that are easier to get a hold of than they ever have been. So we'll give you some ways to actually start your own journey on learning Kubernetes. So let's crack on with what is a container. Now I'll run through this, and then I'll take a drink and we'll field some questions. And we'll try and answer any questions that relate to what is a container. But if we actually don't have any and we've just got some generic questions, we'll try and answer those as well. So here we go. This is pretty much, okay, and I'm being a bit high level here, but this is like a typical application stack. So at the top, you've got what I would say is the most important element. That's the application. It's what runs your business. It's what enables you to interact with customers and partners and things like that. No application, no business for a lot of people these days. But an application, for the most part, okay, has to run on top of an operating system or some kind of kernel. And then that needs some hardware. Even if we're in the cloud, okay, I think we all appreciate that there is hardware below that's actually running our application. So this is our stack, okay. Now, a long time ago now, along came virtual machines or VMware. Now, I know there was more than VMware, and there still is, don't get me wrong, but that was kind of the poster child of virtual machines. But what they did was they virtualized at the hardware level. And we'll come back to that in a second, but it looked like we'll take just a single physical server, right? We would take a physical server that back in the day we would put one operating system on and one application, and probably that operating system and application didn't even touch the sides of the server. So when I say that, what I mean is the server was far too powerful and we wasted loads of resources running just one application on it. So VMware and virtualization came along and said, well, take that overpowered server and we will slice it into multiple virtual servers or virtual machines. And each one looks, smells, and feels just like it's a real physical server, okay? So they've got virtual CPU, virtual memory, virtual disks, virtual network cards. But as far as the operating system and the application is concerned, it's just like a physical, okay? And it let us utilize resources, it let us get to market faster, let us save money, loads of things, right? It was a great thing, don't get me wrong. Well, along later on came containers. Now, if VMware was the poster child of virtual machines, Docker was the poster child of containers, okay? Now, containers do a similar thing to virtual machines in that they virtualize, but they don't virtualize hardware, they virtualize operating systems. So every virtual machine on the left here is, I'm assuming it's on the left and it hasn't been flipped, it will be on the left. And every virtual machine is its own kind of, it just looks like a physical server. Each container on the right just looks like it's a standalone operating system. So we've got 3 virtual machines. We would install, I think I'm going to put this on, 3 operating systems and then 3 applications. And then over on the right, and we'll talk about this in a second, we've got 3 operating systems or 3 containers that we can just slap applications straight on top of. Now, there are a bunch of pros and cons to the container model, okay? I'll concentrate on the pros first. So if we look at the virtual machine model, every virtual machine needs an operating system. So if we've got, I'll just pick 10, okay? 10 virtual machines, that is 10 operating systems. Now that may or may not be 10 licenses that you have to pay for, I don't know, or 10 support contracts. It could be, okay? Not always, but it could be. Either way though, every operating system that we install on a virtual machine consumes CPU, memory, disk space, all of that kind of stuff before we even install the application. So if we have 10 virtual machines, that's 10 operating systems stealing resources that we would much rather use for our applications. If, like, let me just say this, right? If we could run our applications commando, so no operating system, just run our application straight on the virtual machine, we would do that because it's more efficient. Well, if we flip over to the container model, because it's virtualizing operating systems, each container is a virtual operating system. We don't need to install another one on top. So there's only one in the container model, even though we're showing 3 containers, there's one operating system running and it's just sliced to look like it's 3. So that means only one operating system is stealing CPU, memory, disk space, and all that kind of stuff. Only one operating system that needs to be patched and needs to be updated, and all of that kind of stuff allows us to, a term I'm using a lot at the moment is more applications per square foot of your infrastructure. So if you take a physical server, one server, and you install 10 virtual machines on it to run your applications, because containers are more efficient, you might be able to install 50 containers on there or run 50 containers and therefore 50 applications. So more applications per server. Now, look, on the flip side, because there's only one operating system in the container model, if that operating system is compromised by any of those, let's call it 50 applications, then all 50 applications are in danger, okay? So it is a balancing act. The container model is more efficient and more lean, but it poses a different set of security concerns versus the virtual machine model. Now then, I'm going to take a drink, but no questions yet, because I've got one more slide before we break for questions. Now, one of the beauties about the container model is when you package an application as a container, in that container is effectively, let's just call it the virtual operating system. It has your application code and all dependencies wrapped into a container. Now, because the application code and all of its dependencies are packaged as that container, you can develop it on your laptop, package it up as a container, run it in dev, test, QA. That container is self-contained with the application and all of its dependencies. And then when you throw it into production, you know that you're running your application with the exact same set of dependencies that you developed it on your laptop on, and then tested it in dev, test, and QA. Okay. Whereas before we would package everything as a container, like back in the day when we would just package an application and then run it through dev, test, and QA, and then run it in production, we might be, let's just say, because I've been burned by this personally before, we were saving money at one organization and we ran CentOS Linux in all of our environments until production. And in production, it was Red Hat Enterprise Linux. And we got burned at least twice by, once we threw our code into production, we had different versions of library files and dependencies on the production servers. Well, in the container model, everything gets wrapped inside of a container, application and dependencies, so that you know it's nicely packaged. Wherever you run it, you've always got those same dependencies. So what you do is you take that app and dependencies, you build it into a Docker image or a container image, store that on a registry somewhere, just so that it's easily accessible from different environments, and then you run it as a container in your production environment or in dev, test, QA, wherever. And I think I'm going to take a quick pause for questions, and I am going to just say, Nikita, if it's okay, if you can shout out any questions that we might have, and I'll try and answer them. And look, if I can't, I can't. So let's go.
Absolutely. So before we go to Slido, I see one question in the YouTube chat, and I can also put it in the screen. Can you see it, Nigel?
Let me just change my screen that I'm on here.
Or I can read it for you as well.
Is it the one that's, is it from Masood?
Yes.
So containers on the same machine always have the same hardware power, in contrast to VMs, which might have different hardware power. Right, so that's a really good question, Masood. And it's, so to answer the question in the detail that it requires is a bit more than we've got time for here. However, in a production world, when you package your application as a container, and then this is more than we've talked about so far, when you come to run it on Kubernetes, you then package that container or wrap it in a Kubernetes pod, okay? And that pod in a production environment should have a set of resource requirements with it, where we can say, in order for this application to run, it needs a minimum of this amount of CPU and memory, but let's also cap it at a maximum so it doesn't consume everything on the system. So you should, in the real world in production, be saying for all of your applications, this is my minimum set of resources it needs to run, and this is the maximum we should cap it at. And then Kubernetes is clever enough to schedule it to a node that has the right amount of resources, but it also gives you a way to say, yes, a particular application needs more resources than another. So you can effectively package your container, or a pod as we call it in Kubernetes, with a set of resource requirements. And that gets you a similar and potentially more powerful thing than just saying, look, we've got a virtual machine here with 4 virtual CPUs and 4 gig of RAM. It's a similar concept, but I feel if it's done right, it could be potentially more powerful. Hope that answers the question. Do you have anyone in particular you want? Oh, so that what is Kubernetes by Anonymous? We will come to that in a minute. That's on the agenda. Is it good to package the config files inside a Docker image? It depends what you mean by your config files. Okay, so like application config file. So right, generally speaking, no. All right. So both Docker and Kubernetes have a way for you to have application-specific configurations stored as separate objects, but then made available to or mounted into containers at runtime. Okay, it allows you to kind of decouple them, which is quite powerful. But also, it means that when you package up your image, you don't have to package things like secrets and things as part of that container. You can just make them available to your application at runtime. Okay. So that was from so that was a good question. Are there any other container orchestrators you would recommend over Kubernetes? Right, so Kubernetes has all of the momentum behind it. It's got all of the major cloud platforms that support it. All of the major enterprise companies support it. And it's got a super bright future. It's got a strong ecosystem, and it's marching forward at pace. However, Kubernetes is complex. If you want something less complex, this is just me personally, okay? I don't speak for your organization or anything like that. But Docker Swarm is very powerful as well, but it is much simpler. So you have to make that decision yourself and balance. Like Kubernetes is harder and has a steeper learning curve, but it's more configurable and more powerful and has you can bank on it for the future. Whereas Docker Swarm is simpler and it is potentially less powerful, let me just say. There are others out there, but I think Kubernetes is by far and away the front runner. But if you need something simpler, Docker Swarm is pretty powerful as well. I really like it.
We got a question from the YouTube chat as well.
All right, okay. You mentioned that with containers, if the OS is compromised, all applications are at risk, whereas in a VM model, only the individual application would be at risk. How likely is this in practice? Okay, so really good question from Cornelis, I believe. How likely is it in production? It's a difficult question because it depends on what your production environment looks like, okay? So it's true that out of the box, containers are more open than virtual machines, or they're less secure. I don't like saying that, but it's true. However, there are a lot of technologies that allow you to harden your containers for production. So AppArmor and SE Linux, you can apply profiles to your containers. You can drop kernel capabilities for Linux. You can filter syscalls that come from your containers down to the host operating system. So there are a lot of things that you can put in place that require effort and expertise from you that can harden that container environment, okay? It's like anything, right? Security is a defense in depth. And if you just go and turn containers on and run them in production, that's quite a risk. But it's more of a risk than if you just turn a virtual machine on, because virtual machines, every application has its own kernel, and the hypervisor isolates workloads in a stricter way than a container runtime like Docker isolates workloads. But you can augment your Docker security with things like I said, AppArmor and SE Linux profiles, capability dropping, syscall filtering, things like that allow it to then be very secure. So if you just run it in production, then it's highly likely that you're going to get hacked and compromised. But if you take the time and the effort to build that layered security model, and way more than that as well, of course, then it's a much slimmer risk. Now, Nikita, do you mind if I carry on with the presentation for now? And we'll take another pause for questions after the next section, yeah?
Sure, absolutely. And for the audience, please ask the questions at the slido.com, and you already know we can upvote the questions, and the top voted questions will be answered first by Nigel.
Brilliant. So, okay, so can you see my screen again that says why Kubernetes?
Yes, absolutely.
Okay, so I'm going to bust a little bit of jargon first. We love a bit of jargon in the tech community. I hate it personally, but we've got to live with it. So I'm going to explain to you what the terms, and it's two terms really, cloud native and microservices, what they mean. And we'll take microservices first. Now, bear with me, right, because I'm super high level here, but just assume this is a traditional application, a monolithic application where at a very high level, and I'm oversimplifying, but we run all of the application features and intelligence as like a single installer or executable or binary, whatever you want to call it, okay? And what that means is if you want to, let's say it's end of the month and reporting needs to be scaled, you can't scale reporting individually. The only real way to scale it is to scale the whole application by putting it on a different cluster with more CPUs and more memory behind it. And it's painful to scale and things like that. If you want to patch, I don't know, let's just take the reporting system again. It may be that you have to take the entire application down for long, hard, brutal weekends that are full of risk. Entire application down, patch the whole binary just for reporting. And it wasn't a great world to live in. So that's the traditional legacy or monolithic application where everything was coded as a single binary or installer, right? Well, the microservices model, if I just flip back, takes those same components inside the application. So the database, the reporting, the web front end, whatever I've got, middleware, logging, yeah, takes those same things, but splits them out into their own individual components, which we then say, okay, they're all coded individually, which means you can have a small team of developers responsible for the web front end and for reporting and for the database backend and for all the different components, okay? Meaning that we can then, I'll go back. Meaning I'm only on one monitor here, so I can't see what's coming next just because I'm in the middle of moving house, so just bear with me. But because they're all coded independently, it means that you can patch them independently. It means that you can release them on their own timeframes at their own cadence. So you could patch the web front end independent of everything else. You can release an update to the web front end independent of the rest of the application. You can scale the web front end independent of scaling anything else. But the important thing is, even though everything is coded independently, the overall application experience, certainly from a customer perspective or an end user perspective, it's the same. It's the same components. They're just a little bit more loosely coupled now. They'll talk to each other over an IP network via APIs, but customers get the same experience. Whereas us in IT, we just have a lot more freedom, and I'll be honest, a bit more complexity in making sure that everything talks to each other. But generally speaking, the pros outweigh the cons. So we can see on the screen now, I've scaled the web front end and the reporting system. So they've gone from one instance to, it looks like 4 each, okay? But we haven't had to scale the logging or anything like that. So we might have, let's say it's 4 containers running that web service on the front end now, all running on 4 different nodes in a cluster. I know we haven't really talked about what a cluster is yet, but if you scale that to 5, it will be 5 containers, possibly on 5 nodes if you have that many in your cluster. Then also, if something fails, let's say one of the reporting instances fails, it's easy to take that out of the mix and replace it with another one, okay? Whereas if reporting went down in the overall monolithic application that we looked at before, sometimes, not always, but sometimes, that would be like a reboot of the entire application, which was not what anybody wanted. So this model of taking the individual features of an application and coding them and releasing them and scaling them and self-healing them, well, I'm getting ahead of myself here, but let's just say splitting them out and coding them independently is what we call microservices, okay? Each one of those is a service, and it's not a big, ugly application anymore. It's small, so small, micro, small services, microservices. Now, the stuff that we've talked about, that ability to self-heal. So we had, if we go back, in the bottom left-hand corner, we've said to, let's just call it Kubernetes. Kubernetes, we want 4 instances of the reporting system running. Kubernetes knows that we've asked for that. So it will monitor the system and say, I've been asked to run 4 reporting services. Oh, I've got 4 green. We're good. However, this happens. 1 goes down. Kubernetes looks at it, says, I'm supposed to run 4. I've got 3. Okay, I need to fix that. Get rid of the broken one, replace it with a new one, and I'm back to what I've been asked to run. Call that self-healing. But scaling on demand, self-healing, all of that kind of stuff is what we refer to as cloud native. So for an application to be cloud native, it needs to self-heal, it needs to scale up and down on demand, and a bunch of other things. In fact, as well, look, I will say that for something to be cloud native, it needs to be able to run anywhere, not just the public cloud. So as long as you write your application to run on Kubernetes, it will run anywhere that you've got Kubernetes. That could be public cloud, private cloud, hybrid cloud, even your own on-premises data center, okay? As long as your application will run on Kubernetes, it can run anywhere that you've got Kubernetes. And that's an important part of being cloud native. So we've demystified microservices and cloud native. Let's talk about container orchestration, because at its heart, Kubernetes is an orchestrator of containerized applications. So, all right. So I'm trying to look sophisticated here, as if I go and see orchestras all the time. I mean, I do like it, but I'm not an expert, right? This is an orchestra, only it doesn't look like an orchestra at the moment. It looks like a mess of different instruments. We've got the string instruments, there's woodwind, there's brass, there's, what do you call drum, percussion. So we've got all different types of instruments, okay? And right now it looks like a mess. Along comes a conductor for the orchestra and gets them all on stage in the right place. And right now it's starting to look like what you would see on stage if you go and watch an orchestra perform, okay? You've got your string at the front, you've got woodwind, and then your brass, and then all of your percussion at the back. And the orchestrator is in charge of, I don't know, sort of telling everybody when to come in, when to play quiet, when to play loud, when to play fast, when to play slow, how many of the violins and the string section should be playing. Orchestrator is in charge of all of that, and basically just tells everybody what to do. And at the end, we get this fantastic music. Okay, well, stick with me on this because modern cloud-native microservices application is just like an orchestra. So that might not look like an application right now. It might look like a mess of different application components. So we've got database stuff, we've got front-end stuff, we've got reporting, let's call it security stuff, logging. Looks like we've got some middleware in there, but it's a mess. In this situation, along comes Kubernetes as the orchestrator, and it organizes the application so that every application component knows what its job is and what it is to do. So the YAML configuration here would effectively be like the sheet music in the orchestra, right? Kubernetes is responsible for saying, we need more grunt on the front end for the front end web servers, so let's have more instances. Demand's gone down, let's scale that back. Oh, looks like something's failed in reporting or in logging or something like that. Let's do some self-healing there. So in many respects, okay, it's super cheesy, but Kubernetes does for cloud-native microservices applications what a conductor does for an orchestra, okay? So Kubernetes is in charge of making sure our application works the way that we want it to and is able to perform and serve customer needs. Super cheesy, but we'll open that to questions now. And I'll flip screens and we'll see what we've got. So I'm going to skirt that question about which cloud providers you use at ING. Nigel, this is from Anonymous. Kubernetes, any considerations with regards to cloud provider? So I'm very cautious. I never recommend, because it always depends on your organization. So if you're wanting just to learn Kubernetes and a hosted Kubernetes solution, which we'll talk about in a minute, on a cloud platform, the easiest one I've ever come across is Linode Kubernetes Engine, LKE, linode.com. But what it trades in being simple is it doesn't give you as much power to configure it the way you might want it. Now, if you're looking to run something for production on Kubernetes on the cloud, you really need to assess the cloud provider yourself, really, and what their Kubernetes offerings are. We will touch on them in a second, okay? But I feel like we're more and more at the point now where if you already have an existing relationship with a cloud provider and you are happy with that cloud provider, they're almost certainly going to have a strong Kubernetes offering and a strong hosted Kubernetes offering, and we'll explain hosted Kubernetes in a minute. You'd have to justify a reason not to go with your existing cloud provider. Like, we're beyond the point today, I feel, where one cloud provider's Kubernetes is so much better than the others that you have to go with them Most of the time, and I'm careful when I say this, they all offer high performance, highly available Kubernetes solutions. I'm going to hope that we've covered off just at a very high level what Kubernetes is when it comes to it's in charge of making sure that applications that run as containers run the way that we want them to, so that they scale up and down according to demand, they self-heal when parts of them fail, and they all talk to each other the way that we should. Kubernetes makes sure all of that happens. What do I think about the impact of Kubernetes removing Docker support in favor of Containerd? So that's a really good question, okay. I'm going to, Nikita, if you can remember that question about Docker versus Containerd, if you just make a note, because I haven't got a pen here, for later on, after I've explained what a Kubernetes cluster looks like, then I will address that question then. If you can leave it up on the screen as well, we don't have to get rid of it. Who manages resource allocation, Kubernetes or the container runtime? So you effectively manage resource allocation by telling Kubernetes how many resources your containers or pods need, and then setting those upper limits. And then Kubernetes, the scheduler, is then responsible for scheduling that particular work to a node in the cluster that has enough available resources to run that part of the application. And if you have a busy cluster and there are no cluster nodes that are available to run that, then Kubernetes won't run that workload, because it'll say, look, I don't have the resources for it. So in that respect, you drive it at the higher level. You do via setting those resource requirements and limits, and then Kubernetes, the scheduler, is in part responsible for enforcing them. Right. Unless we have any questions from the YouTube channel, I'm going to crack on, because I think I only have, one more section to cover, and then we'll just go a free-for-all for questions, and I'll take that one about removing Docker support. Are you cool with that, Nikita?
Yes, sure. Let me just answer for the ING question. So we use a private cloud at ING, and we run an OpenShift cluster on the private cloud. So I hope that answers this question, and I will just mark it as answered.
Yeah, so let me just touch on that really quick. So OpenShift, just for anybody that doesn't know, so let's just wind this back. So back in the early days of Linux, it was hard, like to install your own Linux servers was really complex a lot of years ago. And Red Hat, and I'm just being brief here, okay, but Red Hat came along and said, we can make it easier to install Linux. We'll give you a hardware compatibility list, all that kind of stuff. So we've got supported configurations for you, and we'll put a support contract behind it, and we'll make it easier for you to install and update and all that kind of stuff. And Red Hat Enterprise Linux was born. I mean, it wasn't called Red Hat Enterprise Linux back in the early days. Maybe it's just called Red Hat Linux or whatever, but you get the point, right? Red Hat came along and said, we'll make this easier, and we'll put a support contract behind it. OpenShift is basically Red Hat coming along to the Kubernetes world and saying, Kubernetes is complex to build on your own, and it really did used to be very complex. It's not as complex now, but it still can be. But Red Hat came along and said, we'll make it easier by wrapping it up in an easy-to-consume way called OpenShift, and we'll back it with support contracts. So just in case anybody didn't know what OpenShift was.
Yeah,
and I'm putting back my slides.
Can
Can you see Kubernetes, the OS of the cloud? Can you see that, Nikita?
Sorry, Nigel, can you repeat? I didn't hear you.
Can you see my screen again? Am I sharing it?
Yes, just a quick question from Francesco, because it's already on the screen. So does it make sense to bring a Docker application in production without using an orchestrator like Kubernetes or OpenShift?
Okay, really good question. Like if you're a small environment and if you're deploying simple applications, you probably don't need Kubernetes. You only really need it as you grow and look to be more grown up or more sophisticated in the way that you manage things. So if you're a small shop with just a small handful of applications, you probably don't need to make the hard effort to learn and deploy Kubernetes. You could just deploy your containers straight to your cloud or whatever, or use Docker Swarm, or use a container service on your cloud. So I still very much feel like while Kubernetes is amazing and it's the future for most people, the learning curve is still quite hard. And if you don't have to, if you're small enough, you can probably just deploy your containers without Kubernetes. And in that situation, Docker Swarm is a good option for you. Yeah.
Yep. Thanks.
Right, I'm going to carry on because time is ticking away. So we've seen this screen before, okay? And I slapped Kubernetes at the bottom of this application, right? You will hear people sometimes refer to Kubernetes as the operating system of the cloud. Now, think about a traditional operating system that sits on top of a physical server, just to make it easier for this analogy, right? And don't get me wrong, when I say any of this, like in the early days of my career, I was quite passionate about compact physical servers. Like I really thought that they were better than Dell servers and all that kind of stuff. And I'm not saying that they are. I mean, they're HP servers or HPE servers now. But I loved server hardware, racking them and cabling them. I loved it, right? But there came a point where I realized that like the customers of the business that I worked for, they didn't know that they were running on Compaq or Dell or Cisco servers or Supermicro or whatever, right? And they didn't care. They just cared that the application ran. Now, the operating system, whether that was Linux or Windows, came along for our application developers and said, it doesn't matter whose server it is underneath, or even if it's, you know, a big Compaq ProLiant DL360 or a 580 or whatever, that's all hidden from the application by the operating system. So if you write your application to run on Linux, it will run on Linux on top of Dell, on top of HP, on top of Cisco, on top of Supermicro, even on your laptop, right? So the operating system abstracted the hardware below. Kubernetes does the same for your applications today in that it abstracts the infrastructure so that you effectively don't have to care whether you're running on physical servers or virtual machines on premises, on the Google Cloud, on AWS, on Azure, on IBM Cloud, or on whoever's cloud. If you write your applications to run on Kubernetes, Kubernetes hides that infrastructure. So in that respect, it is the operating system of the cloud. Now, look, I'll caveat it quickly. Keep looking at my time. You know, an operating system can only abstract a physical server to a certain extent, right? Like if you've got NVMe in one server, like very high performance, low latency memory or storage or whatever in a physical server, and you haven't got it in another, there's not much the operating system can do about that. And the same about some of the cloud things. So if some of your cloud platforms offer different services to your applications that others don't, then there's sometimes not a lot Kubernetes can do about that. But generally speaking, Kubernetes is very much like Linux or Windows. It just sits above your cloud or your virtual machines instead of sitting above a physical server. Now then, how to get started with Kubernetes. Look, I said this at the beginning for those of you who were on the call early. We probably live in a golden age of learning technology, right? When I was learning my MCSE in Windows NT4 and then Windows 2000, I remember having to go to my boss at the company I worked at, and I pretty much had to beg him for an old desktop PC that the business wasn't using anymore, that was in a storage facility ready to be thrown away. But I had to beg him for that, some cables, a keyboard, and a monitor. In fact, I got 2 PCs from him that I stacked in the corner of my bedroom with an old KVM switch so I could flick one monitor between the 2 PCs. And it was in the corner of my room. And to build an NT domain or a Windows 2000 domain and play around with it and trash it was like CDs, and you were like 3 hours later it was built. And then the best way to learn something was to break it. Only when I broke it, it was 3 hours again to build it. And it was really hard work. Not today, okay? If you want to learn how to work with Docker and containers and Kubernetes, I promise you it has never been easier. So on the left-hand side of the screen, for Kubernetes, this would be the path I'd recommend on pluralsight.com. If you work for ING, I'm pretty sure you can get access to all of these courses if you speak to your boss. Getting started, Docker and Kubernetes, the big picture. That's like if you know nothing about containers and Kubernetes, and it will get you running your first container. It'll be like a proper aha moment for you. But now I get it, right? Then getting started with Docker gives you all the framework of how to take an application and package it as a container so that it will run as a container on your laptop, in development, production, wherever. That sort of teaches you the important bits of how to do that. And then getting started with Kubernetes then says, right, now that you've got that application and its dependencies in a container, let's see how we can use Kubernetes to run it on the cloud, on-prem, in production, wherever you want. So sort of going from the top. Then I would recommend my book, the Kubernetes Book. It's updated at least once a year. So whenever you buy it, you know you're not buying something that's been, 18 months superseded and it's kind of like you're going through the examples and they don't work on the latest version. None of that. Always up to date, okay? Then I would suggest a tool called Docker Desktop. This is just a screenshot of it, right? Now, you may not be able to install it on your corporate laptop. I understand that, but if you can, great tool. If you can't and you've got a personal laptop, I'd recommend you install it on your own laptop. Just Google Docker Desktop. It'll take you to docker.com. Dead easy to download. Windows 10 and Mac OS. Click, next, and you've got it installed. Now, when you've got it installed, what you have is you have Docker running. So you can run all the Docker commands to take application code and build it as a container, test it and run it as a container, okay? That might be a bit confusing for you at the moment, but if you take any of these courses or anything, you'll know what all of that means. It's not hard, it's dead easy, okay? So you get a working instance of Docker, but you also get a single node Kubernetes cluster on your laptop as well, which means you can then take that and see what it looks like to use Kubernetes to deploy and manage it in a production environment. The caveat being that you won't be able to get a handle on the Kubernetes scheduler really, because it's just a single node cluster. It's not like a 5-node cluster or anything like that. Now I'm going to touch on hosted Kubernetes very quickly and then we'll wrap for questions, okay? The reason I'm touching on hosted Kubernetes is because it's also a really easy way for you to get a Kubernetes environment and start playing with it, for want of a better term. But as well as that, it gives me an opportunity just to explain some very brief architecture. So a Kubernetes cluster basically looks like this. The blue machines on the left, they can be physicals, virtual machines, instances in the cloud, it doesn't matter. I'm calling these are your masters or the control plane, right? It's where the scheduler runs, all of the other reconciliation loops and things that monitor the cluster and make sure your applications are running. Generally speaking, on the masters or the control plane, you don't run user applications. The machines on the right, these are your worker nodes. It's where you run your user applications or your business applications, whatever, right? But two distinct things, the control plane and then the workload plane or the data plane, for want of a better term. Now, every one of these in the past has ran a bunch of services. It's ran a bunch of Kubernetes services that let it form a cluster and report back on resource usage and things like that. But they also run an important technology called a container runtime. Now, the container runtime is a small piece of technology that understands how to start and stop applications inside of containers. A little bit more than that, but not much, okay? For the longest time, that was Docker. So every Kubernetes cluster shipped with Docker on every node, and Docker was in charge of pulling down your applications inside of those images and then starting them and running them. That was Docker's job. Now, Docker itself does a lot more than just start and stop containers. So it's a little bit of overkill for Kubernetes. Docker did more than what Kubernetes needed. So we've slowly made the transition away from, I'll call it full fat Docker, like, Coke, full fat Coke, to let's just call it Diet Coke or Diet Docker or slimmed down Docker, which is Container D. There is a little bit more to it than that, and my video courses explain that. But just think of Docker as being start and stop containers and a bunch more, and Container D just being start and stop containers, and that's pretty much it. Now, obviously, Kubernetes favors Container D because it doesn't need all the extra stuff that Docker does. So going forward, Kubernetes is dropping support for full fat Docker, and we'll just be going with Container D. Now, from you packaging your applications as containers, you can still use Docker to do that and test, and Container D will still run those exact same Docker container images on your Kubernetes cluster. So containerd still runs Docker images. It just doesn't do all the fancy other stuff that Docker can do. It's really hard for me to explain this kind of stuff in the time that we've got, which is why I recommend my courses. My book, Docker Deep Dive, as well, goes into the architectural differences between Docker and containerd, because to confuse things even more, Docker itself actually uses containerd to start and stop containers. It just does a lot more as well. That's like, okay. But to answer the question that came in before, it's a natural evolution for Kubernetes to want to use containerd because it's slimmed down. It does exactly what Kubernetes needs, and it does nothing more. And that's a better fit than shipping with Docker that does what Kubernetes needs, but then does a load of other stuff as well that's just wasted. Anyway, look, back to this hosted model. This is our Kubernetes cluster, and what a hosted Kubernetes does, and all the major cloud providers offer a hosted Kubernetes service, is it says, I'll take that control plane, I'm your cloud provider, okay? I'll take that control plane, which is hard to build, a highly available high-performance control plane and manage upgrades of it. I'll take control of that for you, control of the control plane. I'll take responsibility for that as your cloud provider and hide it from you, and you just care about the worker nodes, okay? Upgrades in performance and availability of the control plane aspect of the Kubernetes cluster, cloud provider takes care of that. And this is a list of some of them, but there's way more. I mentioned Linode Kubernetes Engine. You know, all of the big cloud providers out there offer a hosted Kubernetes service that says, look, you just come along, sign up and say, I want a 3-node high-performance Kubernetes cluster, build it for me. A minute later, 2 minutes, whatever, you've got it. And then you just add in your worker nodes later and you can run your applications. Look, it's kind of I want Kubernetes, but I don't want to have to learn how to build high-performance, highly available clusters. I'll pick it off the shelf from my cloud provider, please. Dead easy on-ramp for Kubernetes. And if you're wanting to learn Kubernetes, like I said before, there's my videos, there's my book, there's Docker Desktop, but it's only a single node. So if you want to learn with, like, say, a 10-node Kubernetes cluster, go to one of these hosted platforms. Linode Kubernetes Engine is probably the easiest if you're just looking to learn. And on that note, we are finished, and I'll take questions if you want from now. So, do you want me just to go from the top, yeah? Oh, I can't hear you, Nikita. I think you're on mute.
Sorry.
That's
yes,
right.
Thanks for the great presentation. And yeah, we can go just from the top questions, and
okay.
I will also check the YouTube chat.
Right, cool. So makes sense playing at home with Raspberry Pis and K3s or keys? Yeah, for sure. So K3s is for anybody that doesn't know, and I highly recommend it, okay, is like a slim down Kubernetes that was initially designed for devices like Raspberry Pis and Edge or IoT devices. And if you have a Raspberry Pi cluster or the capability for Raspberry Pi clusters at home, then for sure K3s is a solid way to go. So that's really good. Hang on a second. Sorry about that. What do I think about the impact of Kubernetes removing Docker in support of favor for containerd? So it's a very recent announcement. I've not delved into the details too much. Shame on me, but it's just because I'm moving house. And like I was saying before, this is not my office. I'm at my mother and father-in-law's. However, I've been running containerd on all of my hosted Kubernetes cloud platforms for a good couple of months now. I know Google Kubernetes Engine, GKE, has given you the ability to run containerd on their hosted Kubernetes platform for probably a good 3 months now. So I'm well down that path, and I've not come across any issues because containerd runs Docker containers still. So, of course, do your testing before you go into production, make a change like that in production. But it should be that sort of level of plumbing is so low, it shouldn't impact most of us, okay? So I'm not worried about it. It's a natural move forward. Is Microsoft already up to speed with Linux containing containerization? Is it possible to run native Windows containers? Right, so if I understand that question correctly, like, so Azure and Azure Kubernetes service is one of the most advanced and highly recommended hosted Kubernetes services out there. So from that aspect, Microsoft is one of the leading companies when it comes to hosted Kubernetes platforms, and has run, of course, Linux containers on those for a very long time now. To the other part of the question, I hope I'm understanding this right. Windows has done native Docker containers for a long time now, which basically means you can write a Windows, let's call it a Windows.NET application, and run that as a container on top of a Windows host. If we go back, 10 slides or whatever, when we had the server, the operating system, and then the container, a Windows application will run inside of a container on a host that is running Windows. So I'm not explaining that very well. So take a Windows host, install Docker or Kubernetes or whatever, and you can run your Windows application as containers on there. Support for Windows in Kubernetes is a little bit newer, and there's maybe a little bit of work to go until it's feature parity with Linux containers, just because Linux has been with containers and the bedrock of Kubernetes since the beginning. But work is in process to make Windows containers as much first-class citizens as possible. I'm just curious of time. Hope that answers the question. Can I run Hadoop Spark Stack on Raspberry Pi clusters with K3s? I don't know. Probably. Pass, I don't know the answer to that. Communication between the components. Is it something Kubernetes facilitates with, or is this not in scope? Oh, I don't really know what you mean by components. So you need to configure your applications to be able to talk to each other. This is complex, right? It's not complex, but it's complex for like 2 minutes. Kubernetes runs an internal DNS service that does name registration and stuff like that, so that locating other services, microservices, different application components within a Kubernetes cluster is relatively easy. It's all name-based and based on DNS. So that's, I hope that answers the question. That's not hard. Covered in my courses and books, don't get me wrong, and my blog site as well. In private clouds, does it make a noticeable difference to use a container-aware OS when using Kubernetes, better performance and so on? I would say yes. So a container-aware OS, all operating systems, all the latest versions of Windows, and since don't quote me on this, right, but I don't know, the 2.8 Linux kernel, and we're at whatever we are now, 4.5, I don't even keep track anymore, all can run containers. But there are some specialized operating systems that have the fat stripped out and are more focused on running containers. And for building your own stuff, I am a little bit of a fan of those sort of micro operating systems. So I do like them, but you must do your own testing. How master nodes know the status of worker nodes. Again, covered in the book and the courses. So every worker node runs effectively an agent, the Kubernetes agent, which reports back to the masters all the time, and they maintain communications. What are the advantages of using Kubernetes for small apps, especially for high availability apps? Just that it's an investment in the future. You'll then be able to run more applications on it. You'll get the self-healing, the scaling. You're building on a platform that has a very strong roadmap. But if you're never going to be big, it might be too much work for you. And you might not need it. It might be overkill. Nikita, listen, mate, I'm happy to answer more questions, but I don't know if you have a hard stop now.
No, actually, we can spend a little bit more time, but don't forget that we need to give the 2 Kubernetes books as a prizes for the best questions. So can you and I circle back afterwards? Because yes, I can't see all the questions now. I do think that the question about Docker versus Containerd is very relevant and is quite an astute question. So I'd give 1 for that question. Let's have a look. That's a bit small for me to see. Oh, I like that one as well. Is it good to package the config files inside of a Docker image?
if you're asking me, those would be my two questions, because I think as well that's very astute with a sort of security cap on, thinking like it might seem natural to do that, but should we be? And like when you're playing around, of course that's okay, but in production you really would not want to package your configs and your secrets and things like that along with your images. So I would, unless you have a different opinion, I'd pick those two. And listen, look,
Absolutely.
I appreciate all the questions. So many of them have been really good.
And I'm just coming for one second. I asked the question, so you might want to run again. Sorry.
Oh, I missed that. What was that?
Julia, what is the question from you, as I understand, right? I think this question was from Julian, also organizer of this meetup. So if we can pick up one more.
Okay. Let's pick the one below then. Who manages resource allocation? Because I did touch on that, but I didn't clarify it. And that's also like if you're going to be running Kubernetes in production and you don't configure your Kubernetes pods or containers to request resources, then the scheduler is almost blind. It doesn't know what resources are in use. So it's important that you get resource allocation right from day one, in my opinion.
Great. So we have two winners, Seba and Davis Oludere. Please send an email or ping us in the YouTube chat now with your email, and we will get in touch with you for the Kubernetes books. And thank you, Nigel, for having this presentation with us. It was a really great experience. And, hope to see you again in the future.
Absolutely.
Yes. Again, guys who win the prize, please send an email to my mailbox or send a message in the YouTube chat right now. Thank you.
All right. Thank you, everybody.
Have a great day.
Yeah.
Bye-bye.
Ciao.